To solve rational equations, a lot of times we want to work with our equation so that we write a simpler equation that we can solve and then get our solutions from that one. When we simplify our equation from a rational equation, we might introduce roots that don't actually make the original equation true. So it's always important to make sure that you check your answers to the solutions that you get solving an equation that has variables in the denominator of the original equation. Let's take an example of this rational equation, which is to solve 5 over x plus 3 minus 2 over x minus 7 is equal to 4 over x squared minus 4x minus 21. Our first step in solving this equation is to remove the fractions. And when I look at each of these sides of the equation and the fractions, I have variable expressions in the denominator. To remove the fractions, we want to multiply both sides of the equation by the lowest common denominator over 1. And we can do that because we have an equal sign here, and so we have our left side and our right side that we can work with. Let's find what the lowest common denominator is. Our first denominator, x plus 3, doesn't factor any further, but it's attached with a plus between, so it's two different terms, and the length of a fraction bar is a grouping symbol. So we need to show that that is an entire grouping, and we'll put parentheses around that to make sure that we remember. The next denominator is x minus 7. Again, x minus 7 does not factor any further, but it's not exactly the same factor as the x plus 3 was, so when I bring it over on the right-hand side with this work to find the lowest common denominator, I need to make sure that I make it in a new column because it doesn't match the x plus 3 factor that I already have. Now the third denominator that I get from the right-hand side is the denominator x squared minus 4x minus 21. And x squared minus 4x minus 21 does factor. It factors as x plus 3 times x minus 7. Remember, we're looking for the factors of negative 21 that add to get negative 4. And when I think about the x plus 3 times the x minus 7 that this factors as, the x plus 3 factor matches a factor that we already have, so we'll put it right underneath it. And it actually matches the other factor that we already have. So we'll write our x plus 3 in the same column that the first one was in, and our x minus 7 in the same column that we got from our second denominator. So now our lowest common denominator, we bring down every factor that ever occurs, but only to the highest that it occurs within a factorization. And x plus 3 only occurs once within each factorization, and then the x minus 7. So that's our lowest common denominator. Now we're going to multiply both sides of this equation by this lowest common denominator, the x plus 3 times the x minus 7 over 1. So on our left-hand side, we have x plus 3 times x minus 7 over 1 multiplied to the 5 times x plus 3 minus 5 over x plus 3 minus 2 over x minus 7, and then equals, we're on the right-hand side of the equal sign, so we need to multiply that again by our x plus 3 times our x minus 7 over 1 to that right-hand side, 4 over x squared minus 4x minus 21. Now on this left-hand side, we have more than one term. So we need to distribute what we multiplied by to each of those terms. So I'll have my x plus 3 times x minus 7 over 1 multiplied to the 5 over x plus 3, and then the minus, and then our x plus 3 times x minus 7 over 1 gets multiplied to the 2 over x minus 7. And then bring our equal sign, and we have our x plus 3 times x minus 7 over 1 is multiplied to the 4 over, and then on this side I only have one term, so I don't have to worry about the distributive property. but I do want to write the denominator in its equivalent factored form so that I can see how to simplify my expression. So instead of writing the x squared minus 4x minus 21, I'm going to write it in the form of x plus 3 times x minus 7. Means the same thing, just written in factored form. Now what we want to do is within each of these multiplications, so before I hit any plus or minus, I'm just going to box them out for us so that I can have you focus your attention on what I want you to notice in each thing. Because we multiplied by the lowest common denominator over 1, in each of these fractions, the current denominator, I can remove a common factor pair with it and one of the factors that we multiplied by. And then our remaining expression is just the leftover factor times what we originally had. So this will give us, our original had in our numerator, this will give us a 5x minus 35 for what I get in this first box. Now in the second box, my x minus 7 has a common factor pair. And I have to be careful because it leads with a minus in front of this whole expression. So as I distribute this 2 through the multiplication of what factor was left, I also have to think that after that my negative is going to be applied through. So we'll have 2x plus 6 for that multiplication, but then you have to multiply through by your negative 1. So that'll be a negative 2x and a negative 6 because of that minus. On the right-hand side for this problem, I have an x plus 3 common factor pair. I have an x minus 7 common factor pair. And so those all had common factor pairs I could remove, and I have a 4 on that right-hand side. Now, my equation now is much simpler to work with than before. On the left side of the equal sign, I have several like terms that I can combine. The 5x combined with the negative 2x, they're on the same side, I'm just combining them. So 5x minus 2x is a 3x. And negative 35 is a like term with negative 6. So negative 35 combined with negative 6 is minus 41, and that equals 4. Now we want to add the 41 to both sides. And I get 3x is equal to 45. And then finally divide both sides by 3 to get the x on a side by itself. And we get x is equal to 45 divided by 3 is 15. So x is equal to 15. Now that's the solution I got for my simplified equation. I just need to make sure it'll work in the original equation, and basically I just really need to make sure that it doesn't cause any denominator to be 0. Well, 15 plus 3 isn't 0. 15 minus 7 isn't 0. And x squared minus 4x minus 21 comes from the factors x plus 3 times x minus 7. So 15 won't make that denominator 0 either. This answer, x equal 15, satisfies our equation and is a value that's usable.